the internet services to India. I think the other day we have celebrated 25 years completed, and I was fortunate to be have with the team with the BSNL at the time to launch the services in India. So that what you are seeing on this is in the clipping of the newspaper in May 1st, 1995, stating that internet at last reached in India. So these are the tariffs you can see. The tariff, what was the tariff at the time? It was for kilobit of the data, it was thousands of rupees. Today, you see what the tariff transformation, the rate, the market dilution, price war, and all. So I would like to touch upon quickly on this before going to BSNL to provide the internet access at last in India. It was again in 1995, August 15th. And I was the team member at the time, fortunate to have that, be in the award ceremonies. So this was the BSNL dial-up services we started in Hyderabad in 1998. So keeping this just point for information to all that we have celebrated the silver jubilee year of internet in India now. We'll be moving to the point of discussions now. I request any questions also you can raise in between, or at the end we can have the question answer session. So the flow will be like this. We will start with the basics about the OSI, the reference model, how the data communication takes place. Then we move to the different layers of the OSI, how the packet moves, how the flow happens within the interfaces of the different modules of the internet era. Then we talk about the different components. Then we will see IP addressing, how the IP addressing scheme is adopted. Then with the short of the IPs, how I'm going to address that IPv4, IPv6, address translation from private to the public, that is a port address translations. Then we talk about the WAN, LAN, VLAN, and about SD-WANs. Hope the flow from my side will be fine. Then our colleagues will start talking on the MPLS, then advanced MPLS. Then one of our senior officer will talk about what is the challenges today in our legacy existing TDM network, why we are moving to IP MPLS network across the Indian Railways. Can you see all the screen, please?
Yes, sir, it is visible.
Okay, sir. So probably then, yeah, whatever we are talking presently, maybe some officers or officials may be a bit, and I will switch off my video so that we can optimally utilize the bandwidth as well. Yeah. So the officers, you may find that what we are going to talk for some time may be a basics, but I request you to, this is the basic building block for understanding the data communications and the internet protocols that is being used across. All we know that we all know about the OSI, a layered network model, that is open system interconnection model, where it will facilitate for us a data flow across the different devices, different technologies that is being adopted. Why we use again the open system interconnection reference model, that is a layered network model, one is to reduce the complexity, because different vendors makes a different proprietary items which will not fly across global for connectivity for global adoption. So this OSI model reduces the complexities that we have and makes uniform interfaces across all vendors. You might have heard the Cisco. Cisco does sometimes the proprietary items. IBM does different proprietary items. But when it comes for adoption across the different entities, then it will become a challenge to use the technology. So to overcome such standards, so we use the standardized interfaces through this model. And it facilitates the modular engineering and assures the interoperability of the technology. Different makes, different products can be adopted across the globe. And of course, it brings an evolution. We can see the physical layer, the data link layer, the network layer, the transport layer, session layer, presentation layer, and the application. These are the layers of this reference model. Why we take all these things? When we talk about IP-MPLS, IP-MPLS works on layer 3. What is a layer 2? What is a transport TCP IP? Which layer it works? So unless until we have some basic idea of this layer, then it will be a big challenge for us to understand on that. At the physical layer, the data link layer, the network layer, the transport layer, session layer, presentation layer, application. These are the 7 OSI layers of a reference modeling. You may observe how these layers function. What is the device that enables these layers to function? This is the NIC card. Somebody called Ethernet card, somebody called adapter card. So the name is the same. This is NIC card, network interface card built into the motherboard of your system or the PC, the laptop, which enables for these layers to function. The layer 1 is basically a physical layer which may ensure the connectivity, either the connectivity through the hub or the token ring or through the FDDI, fiber data distribution interfaces. The layer 2 uses the bridges or the switches or the hubs. These are the different components what we use on a network. Third one is a network layer. It purely works on IP, Internet Protocol, whereas the layer 2 can work on MAC address, media access control, which we will see down the line. And layer 3 purely works on IP, Internet Protocol, IP packet. The routers routes the packets, whereas switches the packet but not routes the packet. But again, there is a layer 3 switches as well, which routes the packets as well. Next is the transport layer, which is very, very important for the data to reach the destination, starting from source to the destination, starting from host A to the host B. Other is the session layer, to initiate a call, to initiate a session, to terminate a session, to terminate a session. The session layer will take that role. Presentation layer takes about what type of presentation it is, a video, voice, data. If it is a data, what? It is ASCII code or what? It is a video, if it is a MPEG or what? It is a picture, it is a GIF file or image files or JPEG. Application layer, at the end of that application layer takes care what type of application it is going to be, either the FTP, the email, or the HTTP, the browsing the World Wide Web. All that application sits above all these layers. Let us go by layer quickly. The top 4 layers, application, presentation, session, transport layers, are called the host layers, which provides accurate data delivery between source to the destination. There is originating party to the destination party. And in our telephony word, what we call is calling party to the called party. Here, the source is calling party and the destination party is called party. Otherwise, the host layer provides the accurate data delivery between 2 hosts. The media layers, that is bottom 3 layers, physical, data link, and network layers, ensures the physical connectivity and control of the data delivery or the message delivery over the network. Let us see a layer by layer. Application layer provides the network services to the application process. There are the different application process which we'll see: file transfer, NFS, HTTP, DNS, domain names, and we have email, So these are the different applications. This application layer provides the network services to the application processes. Then the presentation layer, data representation, how a receiver should understand what type of data is being presented from the sender or the originator or from the source. This ensures, yes, please.
Sir, can you make the slide full screen, please?
Yeah, sure. Sir, is it okay, sir, now?
Yes, sir, now.
Thanks for correcting me instead of the end of the session. Thank you. Yeah. So the presentation layer ensures the data presentations readable by the other party. If whatever you are presenting, if we can't read it, of no use. And what format data is flowing in, and what are the data structures, and it negotiates the data transfer between the source to the destination for an application layer. Sir, any questions also you're free to ask in between, and we have enough time. We have kept in this module, so let us be very a two-way session, an interactive session, rather the broadcast mode like a UGC.
Rao Garu.
Yes, sir.
So we are actually planning to conduct question answers at the end. So 3:30 is the first hour; it will be over. So
Okay.
at 3:20 we'll stop the presentation for questions.
Okay,
So,
sure, sir.
okay,
Sure,
all the questions I will collect. Whatever the doubts they have, they can post in the chat box.
Sure.
So I'll be collecting these questions and we'll try to answer at the 3:20.
Sure, sir. Sure.
In between, some issue is there. If somebody can raise the hand, so that will be noticed and we'll make him to talk.
Sure, sir. Thank you, sir. Thank you. Thank you. Right. Once the presentation layer is over, the next is session layer. The session layer. That is interest communication. That is a session between the initiator and to the terminator. That is the source to the destination. It establishes the session. We have a different protocol, session initiation protocol and all. So session is initiated in this layer, which establishes, manages, terminates the sessions between the applications. This is the transport layer, which is very, very important. End-to-end connectivity and its reliability, and ensures the data is reached at the destination. And data transferable, establish, maintains the circuits, that is virtual circuits in this data delivery from source to the destination. And it also controls the flow controls and also the error correction. See, we have seen in SDH and TDM also, error correction is a big challenge for us. Forward error correction, we use CRC, cyclic redundancy checks and all. Here also there are error checks. That checks will be done through this transport layer, because all these challenges of error comes on the transmission path only. This transport layer takes care of that. The network layer. This network layer addresses the best path for a packet starting from the source to the destination, what route it has to take. By default, the packet takes shortest route. If the packet takes longest route, there is invariably a lot of delay in reaching the packet to the destination, and response from the destination also gets delays. So routers basically used in this network layer to select the best path, that is OSPF, open shortest path first. These are the typical routing protocols which we will talk down the line during our sessions. This network layer provides a connectivity path selection between the two ends, that is source to the destination, and also the domain of the routing. And most of the times you also might have noticed while browsing your net, sometimes a lot of time is being taken to get a response from the www. World Wide Web. And otherwise it is called World Wide Wait. So till you get the response. The packet routes different routes. One is the transatlantic route, trans-Pacific route. Under the bed of the sea, the fibers are laid. The path takes. So there is invariably a lot of delay in your packet reaching. So all the time packet takes a shortest path, the Pacific route or Atlantic route. If you want to reach your servers at US, the best path is Atlantic route. Whereas if you take a Pacific route, it takes a long haul. So naturally you will have a lot of delay. So the best path selection takes care by this network route. And that is the data link layer, access to the media. This data link layer takes a physical addressing, that is a MAC addressing, it decides the error notification or flow control and transfer of the data. The layer 1, it is a binary transmission. Provides connector, voltages, data 1 and 0 and all. So you can see the peer-to-peer communication. The physical layer transfers in terms of the bits, data layer in terms of frames, network layer in terms of the packets, that is IP packets, the segments, transport layer, session layer, peer-to-peer. The data encryption, suppose an application wants to send to host A to the host B. The first data is come from the application layer, then it adds to the network header. Then it goes to the frame header, then transmits on the up to reach the destination. This is what we are seeing in our SDH also. We had a data and we have a overhead, we have a justification bits, we have all. The similar way data adds to the network header and it adds to the frame header. At the frame tailor, it removes the frame. So it goes to the data and network header. Network header carries the IP address of the source and the IP address of the destination. So along with the data, it carries to the destination. When it reaches the destination, it only extracts the data. The destination IP is discarded there. So end-to-end data is being transmitted. This is the way. If you can see the typical, basically the TCP IP protocol is being used in layer 4 on the transport layer for internet applications. So if you can see on the right hand side, you have a OSI layer, layer 1 to layer 7. Up to transport layer, it is called data flow layers. Above the transport layer, it is called application layers. On the TCP IP stack protocol, up to internet is called the network layer. Above that layer 3, that is layer 4, 5, 6, 7, it is called protocols, which we are going to talk down the line, every protocol onto the transport layer. The TCP IP stands for Transmission Control Protocol and Internet Protocol, a widely and only one protocol that is being used today in internet working. And when we go to the transport protocol, there are the two types we call a TCP and we have UDP. We will talk about on that. Layer 1 and layer 2. This is a physical local addressing systems. You have a MAC address of 48 bits. That is a media access control address, which is connected in a LAN. Then the MAC address is programmed into the ROM of your network interface card. This is also called burn engine. So this is programmed onto your read-only memory. The first 24 bits talk about the vendor code and other 24 bits talk about the serial number. So this is the physical addressing system before we use the internet protocol. This is works on layer 2, up to the layer 2. The switches and the hubs will understand this MAC address and switches the packet from one host to the other host, one network to the other network. The layer 3, which is the IP, totally IP layer, wherein we use the routers for switching the packets or routing the packets in any network. Which path the packet has to route will be decided by the router. Router routes only packet, switch only switches the packet. So router never switches the packet and switch never routes the packet. So layer 3 functions to find the best path through the entire network. If you take a long route, naturally there will be inordinate delay in packet reach the destination. So all the time packet prefers to choose a shortest path. This is a network layer communication path. Addresses represent the path. If you can see 1, 2, 3, 4, 5, 6 in this presentation, talks about the different paths the packet is taking on a router. There are very many routers in these paths. So the packet transits many routers in the network before reaches its destination. This routing helps us restrain the broadcast. When we talk about what is a broadcast, broadcast is talking about something, where to start, where to go. So it keep on broadcast that it keeps a loading on the router. We have to minimize the number of broadcasts in any router. For a router to process the packet efficiently, we have to reduce the broadcast on the routers. We will see what are the mechanisms that reduces the broadcast. Addressing and what is a network, what is a node, how we address this. Network, that is here you see 1, 2, 3, 1.1, 1.2, 1.3, 2.1 and 3.1. The one is called the network, that is which belongs to. Likewise, if we talk about IP address, we will see what is a network and what is a node. The node is that which is the part of the device where this network is terminated or connected. Suppose we have a device, in device, which port of the device you have connected this network, that is called node. So network and the node. Network is a group of the entity and the node is the port or port of a device in which this network got terminated or connected. The network address path user by the router and the node address specific port or device on a network. The protocol addressing. We talk about the network 1 and node 1. That means in a network 1, in one of the device, in the node 1, one port is connected. So that is called node 1. Corresponding to this, what is the TCP IP address is a network 10. With the host, in the network, there are different hosts, different users. So one of the user ARP is 8.2.48 with masking 255.0.0.0. This we will talk separately entirely tomorrow morning on IP addressing system. What is IP addressing? What is the subnet masking and all we will talk about. So just understand for now is a network is of one, other is the host. Where we talk in generic, the network and the node. Here the network and the host. The network layer operation, the host X to the host Y, the user X to the user Y. There are very many routers A, D, B, C, E. There are the very many routers into the path. Each router provides services to support the upper layer. There are upper layer means it is application layer. Application layer seeks the support of the router in providing services to the destinations, to route the packets. The network layer protocol, the host X wants to communicate or send the data to host Y. The application layer here sends the application in this path. There are very many routers A, B, C, D in this network, passes through this way and it enters to host the application. So end-to-end application is exchanged or delivered this way. Each router provides its services to put upper layer functions. So there are very many routers in the network. This packet has to transit all these routers to reach the destination. Thus the host application has delivered to host Y. This is a LAN to RAN routing. Host 4 wants to communicate with host 5. There are the different network 1, network 2, network 3. Network 1 is 8.2.3. This is IEEE standards talks about LAN. LAN is called 802. 803 is the LAN Ethernet. That is Ethernet. 809 you might have heard it is a Wi-Fi. 8.20 it is called your LTE. That is mobile broadband. So these are IEEE standards. IEEE standard 802 talks about the LAN, 802.3 Ethernet. So in this Ethernet, network 1 is connected on Ethernet to the host 4. Network 4 is connected through Ethernet 1 port. Network 2 is connected on token ring. Token ring. This is the token to exchange. Like in railways, earlier you used to exchange the tokens in the single way section. When train goes, the token will be issued to the next, then only the key manually lever will be operated. That's the way, the same way here, the token rings are being issued for a packet to transit, data to transfer. So if you can see how a packet or how the data transit to the destination using a routing table, destination network, you take 1, 2, 3. The 1 is a network 1 which is starting the request, and he wants to send this data to the network 2, host 5. Host 5 is in the network 2, host 4 is in network 1 with Ethernet connection here, with the token ring connection at the receiving end. The routing table for this is destination as to reach the network 2 with a token ring. Hope this is clear. Next, LAN, how this routing table gets updated. From LAN to LAN, again a network 1 with Ethernet connected on host 4, token ring connected on host 5 in network 2. That's the reason if you can see 802.5. 802.5 talks about the token ring. So it has got source Ethernet, destination on token ring, with the destination address as network 2 host 5, starting from destination source to the destination. For this, the routing table will be destination 2, network 2 on the destination, and the token ring is the host where this data need to be connected or data to be transmitted. LAN to LAN, LAN to WAN routing. Earlier we have seen to LAN, local area network to the local area network. We are talking about local area network to the wide area network. Again, it is connected, a source is connected for token ring on network 1 port 3. This is the data. Along with the data, we have added the source address to the destination address. And this is being a token ring. The token ring header is here. So token ring header 1.3 is the source address. The destination address it has to reach on a other LAN through a WAN to the 2.4. That is at the B router, it has to go to 2.4. So source address 1.3 to the destination 2.4 with the token ring with the data. Again, once it passes through the token ring, enters this router, and it extracts the token ring header, then this remains only source address, the destination address, and the data. After leaving this router at A, then frame relay starts. The frame relay again, header will come here, the source address, the destination address, along with the frame and the data. Once this data reaches, passes through this router, it extracts the frame relay header, that is one, and it left over with your source address, the destination address, and the data. Then it is entering at the destination on the LAN with the Ethernet. Ethernet, it is on the source address 1.3 and the destination address 2.4 with the data. Thus the data is being retrieved and at the destination at 2.4. Thus the packet transits on a LAN to LAN, a LAN to WAN. For this, there will be a routing table, how the table will be routed and will be displayed. We will be seeing down the line. Layer 4 to 7. The layer 4 is a transport, layer 5 is a session, layer 6 is a present, layer 7 is application layer. Transport layer, it transmits the packet segments upper layers application it supports, establishes end-to-end connectivity, and sends the segment over one end of the host to the other end of the host, and optionally ensures the data reliability. A transport layer, this is the layer 4. You have a data, along with the data, you have an application port, It goes in the form of the segments. What is the meaning of the data anyway? You know, what is the meaning of the application port? What application that is coming from the application layer? Suppose example, you want to run FTP session. What port of the FTP session? Basically FTP we use port number 20 and 21 in the application. These ports are defined in the application layer software. So application layer sends along with the port number. Then it understands at the destination and globally that this port number is 20 is meant for FTP. Port number 22 meant for something. So we will see what are the port number next slides. So the application presentation and the session layers go through a transport layer to the destination. The applications may be file transfer, maybe terminal session, maybe electronic mail, maybe your browser www. The presentation layer, you are transmitting the data. Is the data is in the form of encrypted or in the form of ASCII code? When you are sending the video and whether it is MPEG form or the sending the graphics, the images, TIFF file, picture files, GIF files. So the present layer takes care which is a readable form by the receiver. The application layer, which is the layer whether these are the computer applications such as the word processor, spreadsheets, and so on. Whether the network applications, it is electronic mail or file transfer or the remote login or telnet, the ping command or trace route command or whatever it is, or the network managements. And the other one is the internetworking application, that is electronic data interchange or World Wide Web. You want to browse some other sites or email, whatever it is, this is on internetwork application. So these are the application layer decides what type of application you are intending or running, whether the video conferencing, voice over IP or whatever it is. So these are all about OSI layers. Then we will move to the next portion is the TCP IP. All these presentations were already shared with you, and we'll keep sharing you before start of the sessions. Sorry for this commercial break. So did you see can you see this presentation, sir?
Yes, sir.
Yes, sir. Yes, sir.
Yeah.
No problem.
Now we are going to see the transmission control protocol and internet protocol, which is very, very widely used and only one protocol that is used for our internet working today. And when we spoke about the different layers of the OSI, to just recap that the layer 3 is one where IP MPLS functions. Layer 4 is the transport. For the layer 4, there are the different protocols that is being used. There are the two type of protocol that operates on layer 4 or works on layer 4. There is a transport layer that is called TCP, Transmission Control Protocol, and the Internet Protocol. Other one is UDP, User Datagram Protocol. We will be talking down the line. Let's understand about the TCP. TCP/IP stands for Transmission Control Protocol. It is a dominant protocol that what I spoke today in the world. It was initially originated from the US Department of Defense using APRA networks at the time. Today's TCP/IP protocols implemented over LAN, WAN. You see, we have seen the TCP OSI layer. Now the TCP/IP layer, how it works, network layer. Network layer is a layer 1 and 2, that is physical layer, a data link layer has been merged here. Along with then is the internet, the transport layer and application layer. If you can see the OSI on the left hand side, all the 7 layers, but here on the TCP side, data link layer and the physical layer has been termed as a host to host, that is end to end, host to the network layer. The network layer is internet layer, the transport layer and the session presentation all will be termed for the application purpose. Here you see in the TCP, the stack, host to host, LAN or the packet radio. Packet radio is through Wi-Fi or WiMAX or whatever it is. The LAN we have just discussed. Internet is the IP. The transport, just now we spoke about, there are the two protocols. That is the transmission control protocol, user datagram protocol. And there are the different applications, telnet, FTP, DNS runs on the transport layer for the delivery between host to the source to the destination. The Internet Protocol Stack for applications supporting the network applications, that is FTP, SMTP, Simple Mail Transport Protocol, HTTP, Hyper Text Transfer Protocol, FTP, the File Transfer Protocol, we will see. Transport, host to host transfer, that's the TCP, UDP, the network layer, routing of the datagram from source to the destination, that is IP routing, and data link, that is the PPP, point-to-point protocol, that is the Ethernet token ring, and what we see as DDI. And physical layer, it is the bits, and on the wire or whatever it is. TCP IP architecture. You see the TCP IP architecture along with the OSI layer, network layer, internet layer, that is the transport layer, and this application layer. On the extreme right, you have on the network interface layer, either through Ethernet or through the token ring or the frame relay or the ATM. The ATM is not that ATM what we have the automatic teller machine. It is asynchronous transfer mode where we use into our SDH technologies. And the internet layer uses different the protocols, ARP, Address Resolution Protocol, ICMP, Internet Control Message Protocol, which we will be going to use all this protocol for a packet to deliver from source to the destination. We will run through in this session only today. Then we will be having in layer 4 TCP and UDP. And then again the applications remains the same. RIP, Routing Information Protocol, SNMP, Simple Network Management Protocol. Protocol laying the data. Each layer takes the data from the above. Suppose example source to the destination you want to send an application. On the extreme left you see an application. This is the message what you call, and you are adding on the transport layer the segment, that is a header, segment header you are adding. Then you are adding a datagram or the network header. Then you are adding a frame header. Then the packet goes. So message adds the segment header, the datagram header, and the frame header. Before at the receiving destination, it extracts the message will be retrieved. There are the different protocols. Just now we discussed it. Running on almost around 6,000 plus ports are available on applications to run. So there are very many ports frequently being used. For FTP, we use port number 20 and 21. Port number 20 used for control and port number 21 used for actual delivery of file transfer. For NFS, network file systems, we use 2049 port number. And TFFP, trivial file transfer protocol, we use port number 69. And TCP, we use port number 06. For UDP, we use port number 17. When a packet comes from the application as a port number 17, it is presumed by the transport layer and it is UDP. If it comes the packet layer 06, it presumes as a TCP. If it comes port number 23, it presumes the port, it is for telnet, and so on. Internet protocol user internet layer. Just now we discussed on this. IP protocol is data from throughout the internet. It performs the routing function wherein the path for which the data will be sent. Again, how you route the packet, it is in your hand. That is a network administrator hand. You can delay the packet. You can move packet. So that is called low cost routing, high cost routing, and everything that is depends upon that. There, that service criteria matters. So there is a gold, silver, and bronze. The services that differs. Premium, naturally gold will cost more. So the routing differs. What is the format of an IP? IP packet normally looks like this on a layer 4, TCP or UDP packet. Every packet in this in the internet networking, you should know what is the source, where from this request is originated, and we should know the destination where this packet has to be delivered. Along with that, it will have checksum for error connection and headers. packet header checksum for error corrections. So the packet works with Ethernet token ring, FDDI, fiber data distribution interface. TCP, UDP, and ICMP, that is Internet Control Messaging Protocol, uses IP services at internet layer. Other application layers in the protocol is telnet, terminal evaluation. By sitting here, you can log into the remote site, a remote host. That is through the transport layer using this TCP. ARP. Just now we spoke about address resolution. These are the very many protocols which you might have heard it. Just I would like to run through quickly. Assume there are two hosts, node 1 and node 2. Node 1 wants to know the internet address of node 2. If the node 1 wants to send the packet to node 2 don't know the packet of hardware of host node 2. How it does translate the packet, how it will send the packet to the node 2, a physical address. ARP is used to solve the problem of translating the internet address into the MAC address or the physical address, such as Ethernet 48-bit. That is nothing but your MAC address. MAC IP address to the, this ARP maps the IP address to the MAC address. Just to see in this example, address resolution protocol, host 1, 131.18.301 to 302, IP address of this, but it don't know what it is. Then it sends this ARP protocol will enables to know the MAC ID of the 3.2, then so that the destination originator will ensure to deliver to the this. Yes, the MAC address of this is this. This is related to IP address of this. So this way, the ARP will help us to map between the IP address to the local address that is called a MAC address. If you don't know anything on internet, you can use the MAC address and send through a MAC address as well. This way all talks about dynamic binding of this thing. Anyway, this presentation is with you, you can go through. In reverse address ARP, that is reverse address resolution protocol. Now, the source don't know his own address. It know only the MAC address. It don't know the IP address. Then how to know its own IP address? Then it will send a request. There is a server, RARP server. The reverse address resolution protocol server will task, okay, particular MAC address, this is the IP address. It sends back. Then the source will know what is its IP is. Maps MAC address to the IP address, vice versa. This is also called a bootstrap. Reverse address resolution protocol, also called the bootstrap protocol. It functions the similar way. An alternative to RARP is bootstrap protocol, which is widely used to find out when I don't know my address, then it will be told through a server. ICMP, Internet Control Message Protocol. ICMP sends the message and reports there are errors on the source host. Suppose there are some errors in the transit. It informs the source that there are errors that is reported on the transit of this during routing. There are very many types of the ways how to do ICF, that is a source quenching, redirect and all, which we don't want. Just to understand about the different type of the protocol, to understand how the packet flows on IP in the OSI layer 4. The primary protocol that function at the TCP/IP internet layer, these are the protocols, that is Internet Protocol, Internet Control Message Protocol, the ping. Many of you might have heard called ping. By sitting at your end to ensure that whether your connectivity is through or not, your network is okay or not. By simple giving a ping command, many people know what is a ping, P-I-N-G, but many people don't know the full form of the ping. Ping is Packet Internetwork Grouper. Many people will, because we know only ping, because we does the ping. So ping stands for Packet Internet Work Grouper, and address resolution protocol, reverse address resolution protocol, bootstrap protocol, routing information protocol, open shortest path first, the border gateway protocol, open shortest path first, and BGP protocol will talk about tomorrow afternoon by one of our colleagues in detail. We will be talking only the protocols that is being used for a packet delivery on layer 4. Layer 3, we have different devices. One is called the router. Router works only on layer 3, which transits the packet, IP packets. There are switches that is coming on layer 3 switches, which widely we use for MPLS purpose. IP MPLS purpose, layer 3 switches. Ideally, switches are at layer 2, but these switches are special switches which is used for layer 3, works with IP routing. Where are the layer 2 switches? Works with a MAC addresses only. We have other component called router. Router means bridge cum router. Bridge is like a hub which bridges between the networks, and router which routes the packets. So router, bridge cum router, it is a hybrid device. Next is the transport layer. The transport layer performs the two functions mainly. One is the flow control, reliability. And there are the two protocols in the transport, TCP, IP, UDP, which we'll talk in depth on that. In the transport control protocol, TCP is implemented a transport layer of both internet architecture and OSI reference model. We have seen that. TCP calls IP module, in which turn calls network devices. This TCP protocol is highly reliable and two-way transmission system. It is byte-byte. It guarantees the delivery of the packet. No duplicate data is received at the receiving end. Data delivered in sequence. That is, it is not so X after X you will receive Z, X, Y, Z. So it delivers in a sequence, and management of the session between the source to the destination, it controls through TCP. Example, sequence that happens. The sender here wants to send the data to the receiver. He sends the data. Then the receiver sends an acknowledgement of data 1. Then only the sender will start sending the data to. He started sending the data to, but the data in between there is an error. The data is not received at the receiver. Thus, the receiver won't send the acknowledgement for data 2 as acknowledgement back. There is a time, it will wait for some time. The sender will wait for some time to receive the acknowledgement of data 2 from the receiver. Because it is not received in time, the timeout, that is called request timeout. What you see on your packets, the request timeout. That is TTL, time to live. The time to live the packet is expired, then packet drops. So again, the sender will send the packet asking him to restart the data, retransmit the data to. Then the sender will send the data to again. Then only the receiver will receive and acknowledges the sender the data to. This is nothing but what we use in our SDH and TDM technology, ARQ, automatic repeat requests, which we are all familiar in that. But what happens by using these ARQs and auto requests and all? So bandwidth is wasted. We are using retransmitting the same for bandwidth is getting choked in the process. The TCP window of flow controls, TCP packet format, how the packet formats, again the data, the checksum, the sequence. The sequence is for what? We have sent a request, the receiver will receive whatever the data received, it will add data received plus 1, that is the sequence, to the sender back. The sender will send the data with sequence number 1 plus 1 so that the continuity will keep continuing, the destination port and the source port. Just now we spoke about ports. The ports, what it is, the application that is running, what port this application is running from the source to the destination. Suppose if I say port number 20, yes, FTP session is going to start. Port number 24, the DNS services is going to be in the application. So this packet format will be the data, the checksum, the sequence number, the destination port, and the source number, source port. The TCP higher protocols uses TCP services for telnet purpose, for FTP purpose, for SMTP purpose. Unique port is associated with each applications, but one unique port number is associated with each applications. But one application will support many ports. One application will support many ports. HTTP, Hypertext Transfer Protocol message is delivered over TCP. Again, next coming back to the UDP, User Datagram Protocol. It is again fits in layer 4 of OSI reference model. This is, whereas the TCP is a connection oriented and UDP is a connection less delivery, provides datagram at the transport layer very faster than the TCP. TCP requires a connection, it takes some delay. That's the reason the packet reaches the destination a bit slower. Whereas this is not a connectionless. The UDP reaches the destination fast. It is a simple protocol with very less bytes of the frame. And again, at the same time, it is unreliable for sending the packet of the data. Delivery is not guaranteed. In contrast to TCP, UDC provides unreliable stream-oriented service. Advantages over the TCP is only less overhead. That's the reason packet is reaching fast. Connection in TCP takes some time. That's why there is a delay of the package to reach the destination, but that is getting addressed in this UDP. Basically, UDP packets are often uses a broadcast for a given port. Broadcast packets are used frequently for all the services of the applications. UDP header, a checksum of 16 bits, message length of 16 bits, destination port 16 bits, source port 16 bits. That's all, nothing else. Whereas the TCP has got a lot of checksum, lot of check port, that of the date, so it delays the packet transit. So the UDP protocol supports the applications of network file system NFS, trivial file transfer protocol, simple network management protocol. Do remember, an IP packet should choose either TCP or UDP. It cannot choose both. That is a must, and we should understand a packet either the TCP or the UDP in layer 4. It cannot be both. Application layer. Two mechanisms available for an application layer, TCP/IP. Popular application that what we use is X.25. How many people heard using the X.25? Very robust protocol that is being used today's the banking industry, ATM industry, and other is the telnet, terminal evaluation, FTP, SMT, DNS. The DNS, domain name service, this is basically to translate IP address to the name, into the name. Suppose www.yahoo.com. It has got some IP address like 168.17.20.40. It is difficult for us to remember an IP address to browse. So what we do, we browse yahoo.com. Then the name service server will translate the name into the IP address, which IP address flows on a network to reach the Yahoo servers. Other is the TFFP, Trivial File Transfer Protocols, SNMP, Simple Network Management Protocol. It's a way most TCP/IP networks are managed. SNMP is based on an agent manager. There is a client server module. Agents collect the information about the host and maintain the status of information about the host. NFS, Network File Systems, and remote procedure called RPC, HTTP, Hypertext Transfer Protocols. TCP/IP application layer uses file transfer. All these are the different protocols that is being used by them. DHCP, Dynamic Cost Configuration Protocol. It is basically to assign dynamically the IP addresses for a packet on a network. Normally, we can manually configure an IP address, but human error and delay in configuration takes use task for us in resolving in case of troubleshooting. Whereas the DHCP automatically configure the addresses over the TCP/IP and network. Again, we have seen about the Bootstrap. Bootstrap talks about reverse address resolution. He knows only MAC address, but I don't know the IP. So DHCP is basing on the Bootstrap. It assigns a particular IP dynamically for a particular MAC address. Configuration of IP address, just we spoke about manually or using DHCP. Communication problem result from incorrect information when you start.
Off করা আছে এ বলে যাচ্ছে
Using the DHCP, IP addressing information is supplied automatically. Many configuration problems are eliminated using the DHCP. How it happens? Again, earlier we have seen what is my address. It has asked in REA, Reverse Address Resolution Protocol. Here it again asks what is my address. It is forwarded to the DHCP server. DHCP server assigns a particular MAC ID, the IP. Hereafter, the IP address is onto the system. The DHCP server.
Excuse me, sir.
Yeah. Yes, sir.
सर थोड़ा सा हिंदी में बता पाएंगे सर, थोड़ा इजी समझ में आ जाएगा.
हाँ, कोई बात नहीं सर, बताएंगे अभी आपको. But again, I have to see how many other than Hindi. मैं तो इसके लिए बता देता हूँ कि I'm okay. I can talk Hindi, Marathi, Telugu, English, no problem. But अभी बाकी लोगों को मेरे को देखना पड़ेंगे how they can. But anyway, आप देख लीजिए. अभी इधर एक लेफ्ट हैंड साइड आप देख रहे हैं. इसका IP एड्रेस मांगता है. How he wants to know his IP address? He don't know the IP address. It has to be assigned to him. So he enters to the network. Basing on this network, it will ask what is my address. Then it goes to इधर से जाती है सर्वर को. सर्वर ये इसका MAC IP देख के इसको एक IP एड्रेस एलोकेट करता है. ये एलोकेशन जो है यूनिकास्ट वन डायरेक्शन में होता है, एक ही डायरेक्शन में, सर्वर टू द क्लाइंट. सो इसको IP एड्रेस इसी तरह से IP एड्रेस दिया जाता है. वंस DHCP IP एड्रेस दिया जाता है, इसके अलावा इसके बाद जो भी आइंदा जो है वो IP एड्रेस नेटवर्क में ब्रॉडकास्ट होते रहती है. ये ठीक है, समझ गए आपको? हाँ जी. Yeah, this is a pool of IP address, free or in use. This way the IP addresses are configured on a DHCP. You have a time for tea break, or we can continue for some time?
Dear spouse, we'll stop here. We will have a small question answers also. We'll ask them.
Please.
We'll take tea break now at 15:45. Start of next session, we'll have some questions. Then we'll start our next session.
Okay. You want us a question session at 3:45?
3:45, sir.
Sure, no problem. So I request all the officers or officials, please keep your questions if you have anything what you are discussing. And Ali sir, is it okay in line with the speed or the